Hello, my name is Ardi and we are going to solve assessment problem 7.6 from Nilsson and Riedel book. So this is the question. Assume the switch in the circuit has been in position A for a long time. At t is equal 0, the switch is moved to position B. A, find the initial voltage across the capacitor. Okay, I think let's do that first. Okay, initial value. So we need to see the circuit at t is less than 0. At t is less than 0, this switch is still in this position A. So we will have that 50 volt voltage source and then that 400 ohm resistor. Okay, so we'll have 400 ohm resistor. And then what else? We have the capacitor. However, because that has been for a long time, the capacitor become open circuit. So the initial voltage is this one here. So we'll have V0. And because there is no current, there is no voltage drop here. So the V0 here is exactly the same as the voltage source. And because the sign is negative on top, so that will be minus 50 volt. And I think this is the initial voltage across the capacitor. Okay. And the second one, find the time constant. I think we will do it later. I want to do the C first. Okay. The final voltage across the capacitor. So the final voltage, the switch is in B, but already for a long time. So let's do at t is equal infinity. So because there has been in a long time, the capacitor becomes open circuit. And this part here, we will have this 20 ohm resistor. And then what else? We have that 5 ohm resistor. And then we will have that minus 30 ohm. Okay, minus 30 volt, I mean 30 volt voltage source here. And the infinity, the voltage at infinity here is this one here. So we can just use a voltage divider here. So V infinity is equal to 20 divided by 20 plus 5 multiplied by minus 30. Okay, and that will be, what is it? Oh, I'm stupid. Let's use calculator. 20 divided by 20 plus 5, that will be 25 multiplied by minus 30. So we'll have V infinity is minus 24 volt. Okay, that's awesome because we now have the answer for A and C. So this is done and this is also done. Okay, now let's do question B. We need to find out the time constant. So we need to draw the resistor at t is greater than 0. So we still have the capacitor intact. So that will be 25 millifarad. And then the other one, we have the 20 ohm resistor. And then we also have that 5 ohm resistor. 5 ohm. And then we have that flip voltage source, which is 30 volt. And I think that's all, right? Yeah. And let's label that. That will be PCT, right? PCT. Okay, we are asked about the time constant, which is tau. And this is an RC circuit, so that will be R multiplied by C. Okay, but then here we have 5 parallel with 20. So 5 parallel with 20 multiplied by 25 multiplied by, because that is millifarad, so we'll have 10 to the minus 3, right? Okay, 5 parallel with 20 is 5 multiplied by 20 divided by 5 plus 20. So that will be 4. 4 multiplied by 25, that will be 100. So we'll have 100 times 10 to the minus 3. And this will be in second, or tau is equal to 100 millisecond. Okay, so this is the question B. Okay, now we need to find out question D, initial current of the capacitor. I think we need to find out the E and F first before D. Yeah, let's do that, and I will need this circuit here. Okay, let's clean this up and let's work on question E and F first. And remember, we have also this initial condition, so let's do that. Okay, so now we have this circuit here, and let's use this as our ground. So this will be our P node here, okay, or VC, right? And because this is minus 30 volt from the ground, this is minus 30. And let's assume the direction of the current. I will assume this is going here, and then this is going here, and maybe this is also going there. This is going to the right. Okay, so now we can do KCL at node VC. KCL at node VC. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. There is no current that goes in, so that will equal to 0, and I will put it on the right hand side. And the current that goes out, the first one is this one that goes through capacitor. Remember that in capacitor, I is equal to C dV dt, right? So the capacitance here is 25 millifarad. So we'll have 25 multiplied by 10 to the minus 3 dV dt. Okay, and this current here, that will be, let's just call that V for easier way. So we will have plus V over 20 on this part, and then plus we will have V minus 30, that will be plus 30 divided by 5. Okay, we now can multiply both sides by 20. Okay, so we will have 500 multiplied by 10 to the minus 3. That should be 0.5 dV dt. Okay, and then this part here will cancel each other, so we'll have V. And this will cancel into 4, so we'll have plus 4V. Okay, and then plus 30, that becomes plus 120. Okay, and all of this will equal to 0. Okay. Okay, now we can simplify this. 0.5 dV dt plus 5V is equal to minus 120. And I can multiply both sides by 2 to get rid of the 0.5. So we will have dV over dt plus 10V is equal to minus 240. Okay, and this one together with this one is a first order differential equation that we can solve. Okay, and let's do exactly that. Let's clean up the board. Okay, now let's solve this by using integrating factor. So we can multiply this by e to the 10t to the both sides, right? So we'll have dv over dt, then plus 10 e to the 10t v, and this will equal to minus 240 e to the 10t. Why? Because we can rewrite this here as this one. So we will have e to the 10t multiplied by p because of the differential function multiplication formula, right? So we will have this as minus 240 e to the 10t, and we can integrate both sides now. So we'll have e to the 10t p is equal to, this one should be minus 24 e to the 10t plus some constant, right? But then we can divide both sides by e to the 10t. So we will have p is equal to minus 24 plus c1 e to the minus 10t. Okay, now our job is to find out what is the c1 there. But we know that v0 is minus 40. So we will have v0 is equal to minus 40. So we plug the t is equal 0 to this equation. We will have minus 24 plus c1 e to the minus 0, right? So we will have that will equal to minus 50. Minus 50. And so we'll have c1 multiplied by 1, right? Because e to the minus 0 is just e to the 0, and that is 1. And that will equal to minus 50 plus 24, that will be minus 26. And we can plug that into the v. So we will have vt, let's just use red again. So we will have vt is equal to minus 24. c1 is minus 26. And then we will have e to the minus 10t. Okay, and this is the answer for question E. Right? That is the answer for the question E. And I think we can do that for question F, which is asked about IT. Okay, let's rewrite. Let's clean up the slide first. Okay, now let's write number F. Number F is the capacitor current IT. Remember that I in capacitor is C dV dt, right? So we will have IT is the capacitor. So we will have 25 multiplied by 10 to the minus 3. And the derivative of this function here, which is, I will have minus 26 multiplied by minus 10. And then e to the minus 10t. Okay, and now let's do calculator here. We will have 25 multiplied by 10 to the minus 3 multiplied to the minus 26 multiplied to the minus 10. Okay, and we will have 6.5, and then e to the minus 10t. And the unit here will be ampere. Okay, and we got this. And we can answer the question D from this one. So I0 plus, that will be this one, right? So I'll have 6.5 e to the minus 10 multiplied by 0. This will equal to 1, so we'll have 6.5. And the unit will be ampere. And I think that's all the question has been answered for assessment problem 7.6. And that's all. See you in the next video. Bye bye.